So now let's look at the question number 9. So we have to find y at 9 pi, where y is the solution of this initial value problem. All right. So what I would do is that I'm just going to go back to my comfort zone, that is this equations editor. So what did we have there was y double prime, and let me enlarge the font size here, y double prime, and then where is it? Okay. So then plus y, and then 4 pi 8 pi, so plus y equals, now we are using the direct delta function. Okay, so I've become slow even on this one now. So what is that? T minus 4 pi and then plus delta t minus 8 pi, right? So you are given a list of formulas for Laplace transform and inverse Laplace transform. Okay, you can pull it up, and then what we will do is this, that and note that our initial conditions are y0 equals 1 and y prime at 0 equals 0. Okay, let me make sure that I got that right. Okay, yes, okay, good. So now we will take the Laplace transform of this equation, because for direct delta, yeah, that will be really a good strategy. Okay, all right, so we got not this. So now we will have the Laplace transform of y, okay, and then the Laplace transform of this guy here. Okay, all right, then plus Laplace transform of this thing here, or this direct delta. I can just write 8 here, and I forgot writing the Laplace transform. So let me write it down. Okay, now you can do this. That is, first of all, the formula sheet that I gave you, it doesn't tell you for what the Laplace transform of y double prime is. It simply tells you that for y prime is s times the Laplace transform of y, okay, minus y at 0. Okay, so if you want the Laplace transform of y double prime, then what you can do is that treat your y double prime as the prime of y prime. All right, so what will happen is we'll have the same thing. The only difference would be that this would change to y prime, right? And y prime 0 is 0. So we got simply Ly prime, right? And here y at 0 is 1, as you saw already, right? Okay, so this is a 1. So we will have s times who, and as I said, this is 0. So s times this quantity. So we got what here? We got s square Laplace transform of y, right? And then minus s, right? So what happens here is that so first we have this for this portion, okay, all right, and then this is So printed in your formula sheet, that is, this would be e to the negative 4 pi s, and that will be e to the negative 8 pi s. Okay. All right. So here we have 8 pi s. Okay. So now what we would do first is that we shall solve this equation for what? Ly, and then take the inverse Laplace. Okay, so we are moving this s to the right hand side, and so then what happens is we get s square, okay, plus 1, and this is a common factor, okay, and then this we got as this here, okay, and so we have this, and then we got we will just divide by s square plus 1, and then go towards finding the inverse Laplace transform. So this is this here, and then we got e to the negative 4 pi s over s square plus 1, and then plus s over s square plus 1. Okay, so who my y will be? My y will be here, L, or inverse Laplace, right, of this function here, okay, and then plus we have what did I do? I was that's what I missed. See, I just copied pasted and forgot changing that 4 to 8. Well, did it now. So here I will change it to 8, then plus we get this L inverse, and then we got this, right? Okay, so what we will do is we are just going to go to the glossary of the Laplace transforms so that we can identify the inverses of these guys. So now so let me just import our formulas here. Okay, so there we go. All right, so when we are looking at this list, you can notice that see this portion here, s over s square plus 1 matches with this, right? So this would be who? Cosine of t, right? Okay, and then for the others we have to do a little more, because here you can see we better split this as e to the negative 4 pi s times 1 over s square plus 1, and let's see that who comes close to this over here. Okay, I think this might be helpful, right? Okay, so e to the negative alpha s, so instead of alpha I got negative 4 pi here, and this is, if I look at the Laplace transform of sine of t, this is the inverse Laplace, sorry, its inverse Laplace will be sine of t, right? So what we have here is that when we look at the inverse on this route, okay, what we will have first is that because of this we will create the, that unitary function, and alpha is going to be 4 pi, right? And then it says we will write yt minus a, that is sine of t minus 4 pi, t minus, actually it meant alpha, so it's like this. Or you can do this here, that is if you want to write it in the other symbols, it's like ut minus 4 pi, right, times sine of t minus 4 pi, right, and which will again be sine of t, and likewise this will become what, u t minus 8 pi, right, and times sine of t minus 8 pi. Okay, all right. So let's take it into the other document. So what we just saw on the other screen was this, that this will be u t minus 4 pi, right, and then sine of t minus 4 pi, right, t minus 4 pi, this would be the same, okay, all right, t minus 8 pi now, and this would be minus 8 pi, and this will simply be cosine of t, right? Okay, so, and this is y t, okay. So what we have to do here is that we have to find y of, I forgot, how could I forget it like that, but anyways, I forgot. Okay, so here we have, what did we have here? Okay, here, so we got, please scroll down, okay, just not going, yeah, y at 9 pi, I didn't, I think I had it right in my mind. So when we go for 9 pi, both of these are going to be 0, and cosine of 9 pi is how much? That's a -1. So that's what our answer here will be. Okay.